So it looks like the numbers have kind of leveled off, so we're going ahead and proceed on into things. I'll turn on the screen. And I know there's a little lag sometimes with internet and technology, so I'll try not to outrun anyone. I would like to go ahead and just do an exercise. If you'll find your, oh my goodness, what's it called? I don't know what it's called. I forget. The raise your hands type thing. If everyone could just raise your hand if you can hear me okay and that you are seeing the screen. You should be seeing SOLIDWORKS on the screen now with 3 different views. This kind of helps me meter what the delay is like. Excellent. Thank you everyone who participated in that. I will put all those down. There we go. Okay, so let's move on then. Again, I'm Andrew Rudisill. They call me the Director of Sales. I feel like I'm the Jack of all trades, master of none. But I am a long-time SOLIDWORKS user and many, I hate to say it, even a couple of generations worth of 3D design now. So a little salt and pepper going on, but that's okay. Up on your screen, you see 3 different models. Just want to give a kind of a quick visual example of the different things we can work with. These are all the car seat, of course, you see over to the far right. You've seen that. We use that in many videos on the screen. A Zodiac boat. For the Marine people in the event, please don't grade my homework, but it's an initial design concept of what an inflatable Zodiac boat could be like. And then what we're actually going to work with today is going to be a scan conversion into a model of a headrest of a car. So that's our subject model for today. We're going to keep this smaller parts, fewer pieces, just so that we can cover more detail in ExactFlat. I'm going to go ahead and I see I have failed to log into my database, so I'll go ahead and just connect to that. If I had not done so, we would have prompted you to begin with. Which brings me to a good segue. ExactFlat is not just a add-in to SOLIDWORKS. We're not just a toolbar with a couple of cool-looking functioning icons. We're actually a database program. And we're a database program built upon a SQL platform. The reason for the benefit of this and the reason for it is for obviously the collection of information. We have a single data source for multiple different aspects dealing with not just the flattening, but the pattern engineering, this different seam types for those who actually deal with sewn goods. And then you have additional information for drawings and then costing. But today we're only really going to show you the 3 of the 5 elements. Design Studio is actually 5 programs in one. It's flattening, 3D to 2D. It's pattern engineering. It's nesting or yield optimization. It's sewn product documentation. That's, to elaborate a little bit there, that's drawings on that has greater functionality than what SOLIDWORKS offers natively. And then there is the costing module. But today we're going to focus on those first 3 because a lot of people, that's where the greatest need is for the most part, is simply let's create a great design, but what am I going to do with it? Well, we're going to work with that. We're going to flatten that. So our database program here, to finish this off, built on a SQL platform, and I'm going to show you the material manager. You have simple file navigation. You have a grocery list of different materials that you may work with. And then within that grocery list, within each individual component, because of the benefit of the database, we cross-reference and link information in and out through the various tables, one of which is the nesting, where we can account for the actual material width, the different units of which you're working with, and then lay rules. What's a lay rule? Well, a lay rule is a process of how to lay out a flat pattern about the fabric. In other words, sometimes there's a bias or a grain or a default direction, if you will, to the fabric, and we need to be able to lay out those pieces accordingly. All older programs out there today, you can type in this information, but why do that? Let's let the software make our life a little easier. After all, we want things to be simpler, right? Life's hard enough. And then we have another section here where we actually catalog some mechanical properties as it all associates all the way back to this original component, the actual material itself. So that's just a kind of quick snippet into the database. We'll discard any changes going on there. There's several other goody things here. Perhaps I'll show you one more. It's kind of one of my more favorite ones. It's called the Edge Features. This database table here, you'll see again here shortly, these are simply fancy little labels, but it's talking about multiple actions that are happening at the same time. And anytime you see a pull down list, this is also accessing yet another database. So we totally intertwine, wow, the various different tables throughout the program. Okay, that's all good and dandy, but let's get to the fun stuff, right? Let's have a fun afternoon here a bit. So we have our design. And where did the design come from? Well, you tell me. SOLIDWORKS can work with many different imported formats, of course, scan to 3D functionality, and obviously creating things from scratch directly inside the actual CAD program itself. So the design input is not an ExactFlat limitation. It's simply the many, and there's quite a few different ways you can input geometry inside of SOLIDWORKS. From there, we can work with what's called a surface model or a solid model. Your preference, we don't really care. So let's kind of step on into our workflow. We do have our nice little toolbar up here at the top. And for those of us who need a little magnification about our lenses, we've got big icons today. So let's see what we got going on. First step is to define your parts. We see lots of different things here, so we need to actually combine these things together in a logical format so that we can create components that we really need to manufacture. And for visual aid today, I was very nice and actually utilized colors. Well, actually, I didn't do it just for you. A long-time CAD user that I am, you kind of develop some good old OCDs, so I like working with things where it's easy to see. And I've created these components in a way that mimics my actual patterns, my actual seams, if you will, where I want parts to start and stop. And we'll just keep plugging right along. We're going to combine the rest of these components because you're like, well, why are these things all broken up? Well, sometimes the way you have to model things, you're not allowed to make it all one big piece. Sometimes you just have to break it apart. And for those who go through CAD training, a lot of times you understand the benefit of only doing half of something and being able just to do a single command by mirroring it over. And that's quite a time saver as well. So, but when you mirror something, you do get this little break right here, and that's not a good thing sometimes, not when you're dealing with a component that needs to be one big piece. So this is our way to combat that. We'll allow that to complete out. We'll execute that command. And first step is done, in preparing your model. Sometimes we get questions, and I don't mean to steal anybody's thunder, but sometimes we get questions on, well, okay, what if it was one big piece, but I want it broken apart? Do I have to model it that way? No. SOLIDWORKS has commands where you can actually do the split lines. It's one of my favorite commands to break surfaces apart. So that's a nice tool to be able to utilize. I'm going to go ahead and convert to ExactFlat, aka I call it just turning it on, checking out a license, whatever terminology you would like to use. And speaking of licenses, ExactFlat Design Studio is available in standalone and floating, or aka network licenses. So here, popped up on the screen now, is the first interface with the database, because we want to assign the material to each of these parts, because truly it is all about the material used. I mean, a Kevlar is not going to act the same as a polyester. A polyester is not going to act the same as a non-woven material, perhaps. So mechanical properties are very important, and creating the association of the geometry to the parts being used is a necessity, and it's one that the user has controls of here. You'll notice different colors. Everything changed colors again. Yeah, well, I did that again to make my life simple. Now I can see the apples and the oranges I'm working with. So I'm going to work with materials, different materials simultaneously here. So you can have a complete design. You don't have to have fragmented designs anymore. Now that this is completed and in place of these initial steps, we'll go ahead and maybe go ahead and start preparing any questions that you may have. And we'll go ahead and move on into the different environments. So we're doing all the work is here inside the actual SOLIDWORKS part file. You notice I haven't left, and I'm not going to leave. We're going to do everything here inside this part file. So if you happen to be using a PDM system, this is great. because you don't have another file to have to deal with. Everything's all in one spot. Now our 3 different environments inside the part file, however, is the model, I call it 3D, pattern, which is actually the 2D. We'll just spin that around, let you see it's good and flat. And then lastly, we have what we call the marker view. The marker view is an interface into the material optimization. And I'm showing you this, not that we're ready for this step by no means, but I'm showing you this so you could see that we've already cataloged in all the parts that we assigned to that particular flavor. So we'll come back to this here shortly. Like I said, it's a little further downstream. Well, don't those look pretty? Well, that's non-manufacturable. Well, you're right. We haven't finished yet. We need to actually flatten and optimize these parts to a relaxed state. Now, in essence, what we have done is we've took the SOLIDWORKS NURBS model and we've converted it into a mesh type file. And within this mesh type file, we're going to be able to utilize this geometry to do pretty much an FEA analysis of the geometry used as it contrasts against the mechanical property of the material you assigned those pieces to get you to the optimal pattern. Now down here below, we have the various different materials already listed, and we'll spread the rest of these out so you can see everything happening going on. And this is a preliminary result, and we have many different algorithms that we can utilize. Now some of the algorithms we've actually already assigned to the materials in the background, such as like an isotropic or an orthotropic. Now, there's different technical reasons for that, but we'll go ahead and move on to one of the pre-algorithms. So we're going to use PELT this time. Now, well, that didn't take long at all. I was hoping it'd take a little bit longer. I was going to tell you about the rest of them. Tell you what, let's go ahead and optimize these and we'll talk about them. Optimization is going to utilize, let's talk about this. Optimization is going to utilize the material properties based off the geometry, the mass of what's there, and it's going to neutralize it the best it can, reducing all the stress or taking away the sag as efficiently as it possibly can. And so while these components are finishing up, we have the other algorithms here. We have the round, we have the wrinkle, the de-wrinkle, and we have the fracture. All these are what we call pre-algorithms or working algorithms that do the initial work to get to a flattened point, and then we hit the little coil spring to optimize the flat, and that's what gives us our results. Now these colors that you're seeing here on the screen, well, that's the temperament that we use so you can visually see where potential hazards may be occurring. Now the darkened areas on my particular template is showing negative energy, or as we Southern boys say, sag. Now it's getting a little droopy about it. Whereas the higher color, we got a little bit of some light blue going on here, is showing areas of positive energy, or in this case, potential stress. Now, knowing where my settings are, and I've got a little shortcut here to it, my strain analysis highlight, knowing my colors already, I know this is only about 5%. And based off the product I'm making, I'm okay with that. So any questions up to this point? We'll give you a moment to get those typed in. Like I said, I'm not going to try to, I'm not pushed up against the clock, but at the same time I'll be proficient with your time. We appreciate you being with us today. So we're going to step on through this, allow us to rebuild and update the patterns. And there we are. Now those look much better. That's something we can manufacture. Now because of the parametric nature of SOLIDWORKS, we leverage that connectivity, associativity, if you will, throughout the model. And one of the things we do, we actually have what we call a find tool. Because if my work was done up to this point and I'm passing it off to you to do the rest of it, you open this up and you're like, oh, what a bowl of spaghetti. Which piece goes to what? We can utilize the find tool. It's a way to actually connect and bring pieces together in an arrangement that we're going to use later in the drawings. Now, sorry, no, I can't show you the drawings today. We don't have enough time. But perhaps next month we'll get back together and we can go over the documentation side of things. So here, you see the little green dot that keeps popping up. Now, this is showing that you have connectivity. And for my good old school pattern people, we call that walk in the pattern, if you will. It's a way that we handle such activity. So I'm just going to utilize these pieces. Now you see we got the different colors. So we got apples and oranges we're working with. And we'll move on into, let's create a seam, because we know this blue part needs to connect to this magenta part. Stretch this out here a bit. And again, leveraging the parametrics, I'm going to turn on auto add mate. And so what that's going to allow me to do, let me zoom in, make life a little easier for everybody. What that's going to allow me to do is to automatically generate information from one side of a component to the next, because SOLIDWORKS already knew that they were coincident or tangent, to use another term. And so we're going to leverage that. And we get a green dot and a red dot, tells us start and stop, or beginning and end. We'll scroll on down through our interface here, and then ta-da! Remember that last database interface I pulled up? Well, here it is again. Here's these labels talking about all the different actions that we have. And in this case, I'm going to utilize a 10 millimeter top stitch. So we're going to grow the net patterns. And that's one of the things that's unique. You don't have to model all the small, intricate detail information in the 3D side. You know, modeling a seam or a zipper or something of that nature, not that you don't have the skills, I'm not challenging that. I'm just saying, why would you take the time to do it? You know, so we're creating a mechanical drawing here that we can just utilize the additional information in the flat pattern. And we're going to utilize what's called a notch, a tick mark, a way to actually create markers from one component to the next, whether you're sewing them together or welding them, you know, through an RF system or different functionality. And just for demonstration purposes, I'm going to put a unique identifier on the first part, and I'm telling you the length of the line, 222.72 millimeters. We keep up with this information throughout the model because this is how we start calculating our cost. Again, because of the database, even though my label said this was a 10 millimeter top stitch seam, this could also be an offset for a composite component or fiberglass part, or maybe it's a vinyl liner and we're going to weld these together. We keep up with this data and we can associate machine actions with this information, and this is one of the ways that we actually roll up the cost. And you can see here I've placed a small little tick mark just to identify that one particular component. Now we can repeat this due diligence throughout. And I tell you what, let's do a different one more. We'll do a different function. This time it's called a hem. And for speaking of my composite and fiberglass folks that are with us today, this is a way that you can actually create your overlaps for your components. Like I said, you modeled the net, and this is just a quick, it's a more lighter weight function, and we can actually grow these components. But perhaps that's kind of a bad thing. We're going to get too much material bunched up here in the corner. No problem. You know, we can utilize different commands to actually notch that away. I'll zoom in a bit and make it life a little easier for you. We'll okay that. So you can see you've got different ways to terminate the geometry that you're adding with ExactFlat, or you can allow ExactFlat to actually merge it together and therefore making your life much easier. Okay, let's just step on through to the next thing and then we can circle back and answer some of these questions that's come in. We'll get into the material optimization, you know, to kind of complete out this phase of the workflow. Here again, we've got the different components already segregated out based off its material type. We're going to enter into the user interface, and I'm going to go ahead and just let these run. We can set a timer for our target or even our percentage yield that we're after based off that target. And we can let these run. Well, we're not looking very good. Well, that's because if you notice, within my lay rules here on the screen, we have different constraints. Again, this associates all the way back to the material that we used originally. Well, how can I change that because I'm not happy with it? No problem. No, you don't have to go back to the database. For all my system administrators out there, no worries. Once you password protect it, you lock that down, you're good to go. We'll just stop this for the moment, and we'll go ahead and make a change. The user has the ability to go in and make a change per job. This saves from having to allow wide open access to the database. A user can come in and actually change the lay rule. I don't know if you saw that change. I'll make one more change, let you see that kick around. And then they can even change the offsets. Perhaps they even call up and say, hey, I've got a sample piece. Can we utilize this piece to get this out, or we have some leftover? Okay. What if we actually put in a sheet size itself? Not only can we do roll nesting, we can actually do boundary surfaces, as we call it. I guess being old school, I call it sheet nesting. And you can put in equalities and so forth. So you have, the user has multiple ways to control how we actually create this marker or nest optimization. So we'll accept that. We've made a change in our rule. And of course it resets. And then we go back in and we enter back in. And things will start dancing around a little bit differently now. But that's still not that good. There's a bias to those parts, and we need these fixed. No worries. By default, these grain lines were put in by ExactFlat as the pieces came out of the flattener based off their x-axis, which our x-axis, is left to right on your screen. We can change that by actually picking on the part. You know what? Let's make this a little more dynamic. Bear with me a second. We'll show you that this happens instantly. Let's do it this way. There's more than one way to get things done. We'll slide this over where you can see both. So let's take this long piece here. It's somewhat easier to see based over here on our right side view. Oh, and by the way, yes, you can do manually static nesting. For those of you who have greater control needs than what I do, you can do that as well. But here I'm going to pick on the part, and I keep hitting my 3D mouse and bouncing pieces apart. Sorry about that. I'm going to create a grain line, and let's see, that one's going this way, so let's make one go this way. I can create a sketch, and I'm going to tell this piece, this is your default. This is the direction I want you to go. I'm simply going to associate the geometry we created to the component, and ta-da. I don't know if you saw that or not, but they automatically changed. And so all the information you're doing is live and instantaneous. And we can nest this again. All looking much better. Get it more compact. Saving us money. Who knows, we may get a Christmas bonus after all. There we go. Now, we would have let that run to a better yield, of course, and you can see your different yield factors and everything, but due to my interruption of it, we didn't get very good numbers, but that's okay. The output of this is a DXF file. It's not just a DXF file, it's actually a layered DXF file. It follows an ASTM standard, or for us old-timers, an AAMA format. So, which simply means we're really quite universal in all the different cutting equipment that we can communicate with. Fabric cutters are different than your CNC routers in the fact that this is the CAM program. Now from here it leaves and goes to the machine, and the machine, if we feed it the information on the layers that it likes, it'll run by itself. Whereas if we were actually creating a sheet metal component, which we could do, or a wood component, we can flatten that out, and perhaps that DXF needs to go to an actual CAM program to what writes NC code. Fabric cutters don't necessarily require such interaction on the user side at this point. All right. So I'm going to pause here, see if I can cruise through some of these questions, and so now would be a good time. If you have one, you've been holding on to it, go ahead and post that, and we'll see what we can get answered here. All right. I'm going to kind of paraphrase this one a little bit. What if you choose, basically they're asking how do you change materials? So if you make a mistake when you assign materials, how can you change materials? No problem. Good question, by the way. And it does happen. There's multiple ways actually to change it. One is actually within the flattener interface, where we had our 3D parts and 2D parts. Right here, material editor, we can change it there. And also, even here in the 2D environment, the pattern view, if you will, right here underneath materials, we can change it there as well. And we can even grab one component and even copy it over to another component. So various ways to get things done. Now I have two of these. What does I do to my marker? Do I have to start over? No. Remember, things are associative. So things will automatically update. Now we still got to rerun our nest, but you can see we actually already got the parts already placed in here. Okay. Also, I guess kind of along the same line, since we're in this environment, we got a couple other ones we'll back up to the first couple of steps here to address, is mirroring parts. You know, you talked about only having to model half of something. Well, if it truly only had to model half and it's truly a mirror, we have a way to take care of that here in the pieces, the piece manager. We can take a component and we can tell it just to mirror it. We can tell it to create asymmetrical mirroring. I mean, give me more parents than I did children to start with. Or we can just simply say, give me additional quantity, you know. And one of the things I failed to tell you, sorry about that, you're probably wondering why did I have 3 parts and only have 1 model? That's because my defaults were already set for 3 underneath the marker sets. So you can have a default quantity, so if you always have a costing lot size you want to compare against, or you make a standard quantity of samples, you know, you can let ExactFlat go ahead and add those components for you and just save you some time. And there's a way to actually make additional markers, and I'm going to get some of these other questions and perhaps we'll show that as well. Let's see here. If you change the 3D model size and shape, how easy does ExactFlat adjust? Good question. Not too bad. I think it changes pretty quickly. So if there is a design change, come back to the 3D space. You know, you would go into your actual 3D design component at that particular point to make such a change. From here, you know, you would simply revert back to your patterns and see this lovely little icon right here? This is your friend. We call it the rebuild command. We kind of mimicked it off of SOLIDWORKS. Sorry, SOLIDWORKS. But you had a good thing going. And we have 2 different ways to actually rebuild. The force rebuild is for us long-time users. It's kind of like a control cube. It's a good way to kind of purge and make everything start from scratch. However, I will caution you. You guys get plumb squirrely with some of your design changes. You may introduce, if you're changing the mass of a part that already had some stress, you may have to come back into the flattening to actually re-optimize the component before proceeding, because you've changed the overall mass of the part, you've introduced your own stress. So, good question though. Give me just a second here. Yes. Here's a classic question. Can I start with 2D and you guys make it 3D? No. Not that we're not working on it, but no. I'm not aware of a program yet, and please post it. I'd love to learn more of being able to take these 2D parts as if they were here and revert them back to a 3D finished product. That's a lot of algorithms, a lot of coordinates points to have to keep up with, but we call that bidirectional, and we're actually working on it. So I guess my development team would be kind of mad if they're listening in today. I'm kind of letting the cats out of the bag. But that's a good question, and we get it often. It is something we would like to do, but it will take some additional time. See, we got a question kind of similar along the line. We got a couple of them similar, dealing with how components come in. How do design inputs come in? Do we convert from other files, import? You know, SOLIDWORKS works with IGES, step files, STLs, OBJs. Oh, I can't remember some of the other ones, but you get the idea. It's pretty broad. It even works with native formats from even other CAD programs. So if your company is a non-SOLIDWORKS company, if you will, but yet you like Design Studio, I know some CAD programs natively come over, so you can actually work from that design, even though it may be, quote, a dumb solid or a limited functioning solid. You can work with that to pick the services you want. If we had additional information here on our model, we've just simply done what we call a body delete, to use a SOLIDWORKS term. In other words, we'd have turned off, if you will, all those other parts and only worked with the ones you selected. If I'd only selected this one particular blue piece here, I could totally ignore the rest of the model. So good question. All right, moving right along. A couple of little benefits. Again, a lot of times we don't get to spend a lot of time doing it when we're hosted by other people, is creating markings or identifying different components within the parts, such as a label, if you will. I'm just going to create a square. And we can utilize SOLIDWORKS tools to actually dimension and control these components. assuming Andrew can actually pick them. It's kind of hard to see blue on blue, isn't it? But so here we can actually create a component, and then we'll exit this sketch, and then we'll associate that geometry with a piece of hardware. Now, you could take the time to model a zipper or a D-ring or snap or button, various different Velcro even, components that are used, within some products or flexible materials. This could even be a particular label, like we're getting ready to do, for maybe a film component, a stretchy film, an elongation type shrink wrap component. Because we're built on a database program, well, we have a database for that too. You can have a grocery store full of different components that you wouldn't want to necessarily take the time to try to model it on a 3D component, but you want to associate it in order to get placement and then eventually even cost. Because somebody had to make this label or the elastic or whatever that other one is. What is that? Stainless steel rivet? That's an item you had to purchase, so we need to keep up with that cost. So one of the ways we can do that is we can create what I call a phantom BOM, an associative BOM. SOLIDWORKS natively can create bill of materials by itself, but it's looking at the different file components that are coming and going and being linked within. So we're actually working within that part file, so we create a different way to create a phantom BOM ourselves. So this particular now sketch is now associative with the hardware component. And I'm utilizing the color. In fact, let me just do this here quickly. I'm utilizing the color of the sketch to visually feed back to me what that actually is. And that color then also propagates out on our drawings, just like the different colors of our seams and notching and so forth. So if you're a manufacturer who has to work with different countries or various different languages, text, written documentation is not always the most friendly thing to use. But colors and symbols are. So this is a way to be able to communicate throughout different manufacturing locations by using geometry. Good questions. Excellent. Well, I see we're out of our, quote, allotted time, if you will, but I'm happy to stay on. I think we may have one question here I haven't addressed yet, per se. But I wanted to make you aware that, we targeted about 30 minutes. We've gone slightly over. In essence, what I would like for you to take away from here today is simply ExactFlat is a complement to your SOLIDWORKS workflow. Now you can have one model that actually communicates everything that you're already doing with your SOLIDWORKS. Your metals, your plastic molded injected parts, your wood components, what I call hard goods. And you've got a downstream process for that. Like I said, you've got those CAM programs, you've got a complete tool set already in place. But what about the other guys? The other guys we don't really talk a lot to, but yet they've got to get their work done. And they've got to create a fabric component or a canvas base or a film. They've got to cut the composites. We can get all kinds of composite files in here, but eventually that has to be cut from a rolled fabric-based material. And what we can do now is have everybody working from the same model. Not only are we going to create the mold from this model, but we're also going to cut the fabric that actually directly relates to that mold. And we can put an offset in here to make sure we have no gaps in our components when we lay them up. And then we can actually output them nested to optimize our material consumption, because after all, those manufacturers, they just give that material to us. It's cheap, right? Not. We all got to be cost conscious, and this is a way to get things done. Trust me, as a former director of engineering, R&D manager, cost is one of the biggest issues we always have to work from. And you know what? I'm going to give you a sneak peek. I'm going to let you look at one little thing here called our results tab, to where you'll be able to visually see the different ways of costing and how they can break down, how you can even drive up and down the quantities of the cost. The costing environment, they don't allow me to have everything here today, so I don't leak everything out and show you. But it's going to be an awesome 2014 if you guys decide that ExactFlat is something that can help you. We're here to help you. We're practitioners. The majority of us are, like I said, I spent 20 years on the other side of the mouse and only about less than 2 years now on this side. So, oh, sorry. Let's see, we got a couple more questions that's come in. Okay, I have a good question. It has to do with grain lines. One of the things that you can actually do, if the geometry allows it, if you will, I'm going to pick a component, and I'm actually going to create a sketch, and I'm going to associate this sketch to the actual SOLIDWORKS model. And perhaps blue is not a good color to have done that with. I'm actually going to pick this component, pick that component, and I'm going to make them collinear. So I'm actually going to put that grain line right there actually on the part. I could even trace that part, probably done a coincident edge. I'm going to take a grain line command, and I'm going to associate that grain line to that part. Let me turn this back on to solid. Let's go back to our marker, and boom, that component has now changed. But I'm utilizing the actual geometry of the part to control the grain line. So this is a quick way to, associate geometry and keep it linked in. Good question. How do we, let's see here. Okay. We got an advanced composite person here posing a poor old guy a question. Okay, let me see if I can understand your question. So I apologize if I missed the mark. But there's multiple ways to handle, I say grain control has more to do. The question is based on controlling the orientation of the composite parts, because for those who don't know, as you layer up the composite, as you layer them up, as you build up your layers, they have to have constricting grain direction, orientations. So you can't just use the same piece like we have here, 5 times, because you're going to create a weakness. You're going to create a bias in that part, and that's not what they need. They need to be able to have use the bias of the fabric to create strength. So one of the ways you can do that, like I said, is utilizing the grain command. You can actually even create an offset geometry and have multiple layers even pre-modeled, or even associate them out. You could even utilize your surface bodies naming, that we used earlier, as a way to distinguish between, inside layer, layer 1, 2, 3, 4, and 5. A lot of the customers we have in the what we call insulation blankets, the thermal blanket industry, will actually label those. There's a hot layer, which is probably the area that's being touched into the surface. Then there's thermal layers. There may be 2, 3, 4, 5 thermal layers, depending on the thickness they're working with. And then there's the outer layer. And so they're actually working with 3 different material types, but then they're working with multiple layers simultaneously. This is where you can actually kind of leverage SOLIDWORKS. So if you have a solid model and you want to just create a representation of those layers, you can use an offset surface and be able to get those. And then you can just simply have your arrangement. You can create different grain lines by controlling those, like I said, by creating your sketches. And then you can visually see layer 1 to layer 2 sitting there side by side. If you can imagine that we would actually have copies of this. So as the parts grow or shrink, depending on which way you're offsetting, you'll be able to see each layer simultaneously. And that way you're assured that you have the control that you were asking. I encourage you to attend one of our user groups whenever we do a presentation. We do a presentation around composites, and we actually have a couple of videos on the website now dealing with composites. So I encourage you to check those out. Excellent question, though. Oh, yes. The infamous metal question. Absolutely, this could be made of aluminum. Sheet metal's not that thick. And so, again, I want to be very clear there. Like I said, I'm a SOLIDWORKS user, and I'm somewhat of a practitioner, a practical person. We only work with a single surface, okay? So if you're getting up ½ inch or thicker, if you're working with only a single surface, you could get deflection with the secondary surface. Now, you could make a reference plane that's kind of half the thickness, and perhaps that is acceptable, and it all goes back to what your tolerances are. But a good question. But there is no Poisson ratio for metal. You're right. It's a K factor. One of the units we work with is newtons over meters, and so you can actually we can get those converted down and we can utilize your K-factor as a way to do that. So good question. So for all our sheet metalers that are out there who deal with gusset indentations and so forth, we can help you. You still utilize SOLIDWORKS sheet metal flattening for the ruled bends and things of that nature if you like, or you can do it all in ExactFlat. It's your call. Still a good question. Still a good question. Okay. Well, it looks like the questions are starting to taper off. Ladies and gentlemen, again, I'm Andrew Rudiso with ExactFlat. I welcome you to follow up with us after the webinar event. I hope we've addressed a lot of your questions. I know we've got many responses from the web event from last month, asking quite a wide range, and we wanted to try to take this time today to address them. I would like to ask, before everybody totally cuts out the door, if I can get to the list here real quick, if you would to show me by using your little show of hands, your raising hand thing, if you'll raise your hand for me if I answered at least one of your questions or I helped you understand ExactFlat more. Wow, thank you. Now I'm going to take a screenshot of this and I'm going to send this to my superiors and I'm going to help you guys. You guys are going to help me with my evaluations. So this is awesome. Thank you. You're a good group. Thank you for the questions. Like I said, you're free to check out and head out. Email me. Here, I forgot to give you that, didn't I? I'm going to put in the chat box just in case you don't have it. My email address. If you think of another question later on, I can also be reached through our website, and you're welcome to email our website or go to our website for the email. I think there's a generic one called like sales@exactflat.com. That just address it to me personally. Just send it to Andrew, and they'll get that to me, and I'll get you an answer from today's event. So excellent. Pedro, I see your other question. Email me, and we'll get that question answered for you. I wanted to show them the ExactFlat Design Studio for SOLIDWORKS today. Thanks, folks. Hope you have a Merry Christmas.